As we start getting into these rational functions where you start seeing the variable x in the denominator, you're asked some similar questions that you saw with power functions, because these are just basically power functions that have negative exponents. And negative exponents, of course, puts the variable in the denominator. So you're asked here, if g of x equals 7 over x to the fifth, what happens to g of x as x doubles? So let's have a look. If you were to double x, make it 2 times x, you would have 7 over the quantity 2x raised to the fifth, which you would raise both of these to the fifth power. 2 to the fifth power is 32. And so what you actually have is, now you have this 32 in the denominator, which means it's 1/32 of 7 over x to the fifth, which is 1/32 of g of x. This 1/32 you see here, this 1/32, is the same thing as multiplying by 1/32, which is also the same thing as dividing by 32. So either one of these answers would have been acceptable in these blanks here. You would either have multiplied by 1/32 here or divided by 32 here. And so they behave very similarly to the power functions, except as with power functions, as x increased, so did whatever it was over here. Just you had to figure out what the factor was. With these, you have what's more of an inverse variation or proportion, where x increases, this is going to decrease. And that's what they get into in the next one, is that you have the time in seconds t needed to fill a tank with water is inversely proportional. So that's when you start getting power functions with negative exponents, to the square of the diameter d of the pipe delivering the water in inches. If it takes a pipe with a 4-inch diameter 48 seconds to fill a tank, write the equation describing the relationship. So it's not asking you an entire question for a proportional issue like we've seen with the direct proportion in the previous sections of chapter 7. This just wants you to get the formula for it. But I'm still going to start it off the very same way. It says here that that's inversely proportional to the square of the diameter d. So the time t is inversely proportional to the square of the diameter d is the same thing as saying t is going to equal some constant divided by the square of the diameter. So that's the general formula. Now to get the actual equation that describes the relationship, I got to figure out what k is. And that's what this information here is going to help me figure out. The pipe has a 4-inch diameter. It takes 48 seconds to fill the tank. So when t is 48, d was 4. And so when you work that out, you get 48 equals k over 16. You'd multiply both sides by 16, and you would get 16 times 48 for k, which is the same thing as 768. So the formula you're going to have up here is 768 divided by d squared. And that's the formula you would have for this. And that is the end of this example as well as this video. If you have any additional questions, please make sure to bring them up during class.